Okay, hello everybody and welcome to today's Geo tutorial. I'm joined once again by Charlotte Foster from the Field Studies Council, and today's session is called Graphical Skills in GCSE Geography. As usual, if you have any questions or comments, you can leave them in the chat box on the right hand side there. We'll get to those at the end if there are any questions. You may find it helpful to have a pen and paper to hand if you want to take any notes. We will have the PowerPoint to this session on the Geo website. In fact, it's already there, so you can download that now or later. And we'll send you all a link with the full stream on YouTube that you can watch at a later date if you would like to. Okay, so I'll hand over to Charlotte now.
Lovely, thank you, Aaron. Yeah, welcome everyone. As Aaron said there, I'm Charlotte. I'm the senior tutor at FSC Flatford Mill. So I work with lots of GCSE students all year round, and it is my pleasure today to share with you some top tips on a really fundamental skills element, graphs. They're so useful for our understanding of data, especially really big data sets that really tell us about the geographies of the world around us, but would be difficult to interpret otherwise. However, they also have the potential to trip us up if we use graphs poorly. So it's well worth applying ourselves today to look at our graphical skills in GCSE Geography. Aaron mentioned that the PowerPoint is available, and indeed it is. There's also a handout for this, so if you have downloaded it already or opened that, you can work through it as you go, and that just sort of has some templates for the tasks we're doing. But if you don't have that, no worries, you can still do the tasks as we go. That'll make sense. So let's have a look then at why we're doing this. Our aims for today are using geographical contexts. So we'll try and use a whole range of data sets to give meaning to the graphs we're looking at, and they should be linked, or they are linked, to the sorts of topics that you might do in GCSE. So even if you might not have covered it yet, you will do, and that will hopefully help them to make sense. But specifically with those graphs, we're going to be choosing and justifying appropriate methods of data presentation, choosing the right graphs for the data we've got. We'll be evaluating the strengths and weaknesses of a range of those graphs as we go through. And finally, we'll be looking at how we read graphs and interpret them to help us interact with the data. Okay. I would say at this point as well, although I go through a whole range of skills and types of graph, it is well worth looking at your own specification or your own exam board's links to the skills that you need for doing your specific exam. Okay, this is a generic session. So first up, we're thinking about why do we use graphs? I've got three data sets on the screen here that you should be able to see here. Got example one, which is a box pop is like a short survey, so it's a survey data basically, which asks people the question, what would or has most persuaded you to change your own lifestyle to combat climate change? So it's about what people are doing to react to climate change and change their behaviours to improve the environment. So there we've got lots of word-based answers, and we've got a bit of information about the age of the people who gave them as well. Next to that, we've got the table, distance down the beach, and then the beach height, which was recorded as we went down the beach. And then at the bottom there, we've got handwritten data this time. So this might be something you would collect in the field as you're sort of measuring the river. And it's from a river study. They've worked their way down a few sites, and they've taken some measurements of depth, width, and velocity. So I've got a brief task for you there, guys. If you are watching live, it would be great if you wanted to put any feedback or comments or ideas in the chat box as you go. So for any of these data sets, I would like you to have a think about what is the main trend shown by that data? What might you put to describe the main trend shown by any of those data sets? Give you a minute to think about that. If you're doing it later to maybe discuss in class. Okay, so what might we put there? well, maybe the easiest one to address is the table, the beach data. You can sort of see just by looking at the numbers, they seem to go up as you go down the beach. Okay, so as you go down the beach height gets bigger. That makes sense, doesn't it? So a general trend, fairly easy to access there. But what about for the others? They're much less easy to just interpret or give the main trends for. You might sort of know what you're expecting to see with the river study. As you go downstream, you expect rivers to get wider, deeper, and know about the characteristics of the river along the long profile. With the word-based data, really hard to pull out any main trends. You'd have to read it, wouldn't you? So let's have a look at that in graphical format then. You should now be seeing a few graphs instead. So let's go again with our beach profile data first. This is exactly what we'd have expected, okay? You might have said just there that the trend increases with increasing distance along the beach gets higher, and it absolutely does. But now we've got this in a graph, and this type of graph is a cross profile or a landform profile. We can see, well, yes, it does increase, but it doesn't increase at a different rate. We're also able to tell exactly how much the height increases by, and we could even look at the sort of cross-sectional area underneath that graph if we wanted to see how much volume there was of beach material. So we can do a lot more with that. With the others, they've definitely improved in terms of our ability to interpret the data once it's in graphical formats. So for the river data there, for example, the scatter graph, we're able to see all of those data sets that were handwritten before at once because we've calculated it into discharge. So instead of the raw data, we've now got the calculation of river discharge in QNX, and we've got it plotted against distance downstream. So we can see that, broadly speaking, it does increase with distance downstream, not quite a linear trend. With the word-based data, this has taken some processing to get into graphical format. What we've done is gone from word-based or qualitative data, I'll come to these key terms in a bit, and it's actually been sorted out or coded into different themes. So we can see that some people were talking about education has made them change their behaviour towards climate change. For some people, it's a love of nature. They love nature, they want to protect it, and so it's made them take action against climate change. The other one there is impact on people. So as well as impacting on nature, things like rising sea levels, affecting coastal communities, that sort of thing, or changing agriculture or changing sort of fishing capabilities, that's made them change their behaviours. And what we've done there is we've looked through all of those quotes, counted up how many times people reference education, love of nature, or impact on people, and then we've got a number to plot on, in this case, a bar graph. So we can instantly see, instead of reading through all of those quotes, we can instantly see that actually a love of nature is the main factor making people change their behaviour to combat climate change. So that's just a quick lesson there in why we use graph. It's so much easier to interpret trends, to make sense of big data sets if you've got a lot of data trying to tell you something, and that there are different types of graphs for comparisons, for proportions, for relationships, for showing distribution, all that sort of thing. So there's a lot of general reasons why in our lives we might want to make use of graphs, and we use them every day, not just for our geography GCSE, of course. However, it's also important that you understand these and have skills, build your skills around graphical kind of presentation and graphical interpretation. And we'll have a quick look now at how that links to your specifications as well, just so that you're clear on why you need to know this for your GCSE. So as you can see here, you need to be able to select and construct appropriate graphs to present data. And that word appropriate is really something we're going to be looking at through the session, working out why we might choose one graph over another, and actually how it can be less meaningful if we choose an inappropriate graph for our data. We're also going to be completing some graphs, or working out how to complete graphs to a good standard. So you need to be able to show the ability to plot points, use and select appropriate scales, decide which axes to use, and so on. In your GCSE, you'll need to be able to complete and interpret graphs on maps. So that might be choropleth, isoline, dot maps, proportional symbols, and flow lines. In your GCSE, you need to have or be able to show a familiarity with line graphs, bar graphs, and compound bars. scatter graphs, pie charts, histograms, and photos as well. And finally, you need to be able to extract, interpret, and analyze information from graphs. Okay. As I say, it is worth checking your own GCSE examination board specification because things like population pyramids, radar graphs, kite diagrams, triangular graphs, and different types of image, such as satellite images, also appear on some specifications. So do check either with your teacher or directly on the specification, and there'll be a list of the skills that you need. So with all that kind of background behind us, why we need to use graphs, why they're useful to us, and why you need to know it for your GCSE specification, we'll get ahead then and start thinking about how do I do this then? How do I approach my, my graphical skills? What do I need to know? This all starts when we're choosing and justifying appropriate methods of data presentation with the type of data that you have. So we're going to come across a few kind of key terms here now, and in your handout, if you're using it, there is a little table with kind of a matching links exercise. So you can, of course, just take notes, but if you want to use that, then it'll help you keep track of these key terms, some of which might be new to you. So before you can draw a graph, you need to work out what type of data do you have. Well, the first key term is data itself. What do we mean by data? Might seem a bit scary, but really it's just about information. Information you collect or you're given about something. And often in numerical form, but not always. Which brings us to our next key term, which is the idea of qualitative data. So qualitative data, as you might know, is information such as words or images. It could be a painting of somewhere or a picture of graffiti on a street. Or of course it could be the words such as the data I showed you just a moment ago at the start about the questionnaire on climate change. Could also be sort of words like types of litter, so you might list sort of plastic, cans and so on. They're words that would also be qualitative data. This generally fits into two categories, namely nominal data or categorical, and this is based on categories or names. So things like ethnicity, plant names, there's no ordering, there's no order between whether it's an oak tree, a pine tree, sycamore tree, and so on. They are just different categories you might count up within these. Colours as well, that would all fit into that. Ordinal data is another type of qualitative data, and this is data that has an order to it, but it's not interval data. Now, I've used lots of words there. So interval data is where each unit is of a certain and given size, whereas ordinal data just has an order, so it's easy to tell lowest to highest. For example, if you're judging environmental quality on a scale from 1 to 5, where 1 is bad and 5 is good, it has an obvious order, 1, 2, 3, 4, 5. However, there's no set amount of environmental quality between something you give a level 2 or something you give a level 3. There's no set amount between those 2 points on the scale. We just know that the area with a level 3 has a better environment than the area with a level 2. So that's ordinal data. As well as qualitative data, we also have quantitative data. So this is numerical data based on numbers. And again, that can take a couple of forms. So for example, it might be discrete data, and that is numerical data which we can only have as integers, so it's counts. So for example, you might do a traffic count and count the number of cars going by. So maybe the High Street had 12 cars, King Street had 40 cars. You couldn't have 40 and a half cars though. So it has to be discrete data. Another option is continuous data. And this is numerical data again, but it can be described in parts or decimals. So for example, you might measure the depth of a river, and you might do it in meters, in centimeters, in millimeters, even in nanometers. But the point is that it's always been split down, and each kind of unit or gap between each unit is the same, which would make it interval data as well. So continuous data can be split down into parts. You have halves. Now that's fine. So if you're given a data set, you may well be able to name what type of data it is. But how does that help us with our graphical skills? Well, let's see why that matters here. On the screen, you should be able to see, again, some river data. So I'm just using this simple example. I've got 5 sites on my river, and we've measured the depth at those 5 sites, and it's shown there in a table. Okay. Now here, I've shown it as a line graph. Now, if we don't take into account our type of data, the graph we choose might be misleading. So on this line graph, for example, it suggests, if you read across from the axes, that at 0.3 meters depth, I would see that occurring at about site 2.5. Or similarly at site 3.5, I would expect the depth to be about 0.48 meters. And that doesn't make sense, does it? There is no site 2.5. That can't be a thing. So the way we'd expect to be able to use a line graph like that is null and void. It doesn't work. We're misleading the viewer with suggesting how we can interpret our data. And we can't, because we didn't measure anywhere between site 2 and site 3, for example. So we don't know what the correlating depth might be. So instead, a better way to draw or represent that data as a graph, you might already have guessed, is a bar graph. So here along the x-axis, I've got my site number, 1, 2, 3, 4, 5, and I've got the depths that they relate to. Okay. So we can clearly see here that there is a trend. As we go downstream, the depth gets bigger, increases. However, it also shows an even rise, fairly even rise in depth as we go between places, because our site number, well, it's ordinal, well, they go in order, we have no way of knowing how far there is between those. So it might be more useful to a person trying to interpret this data to draw it as a scatter graph using the distance of the site downstream rather than just the site number. So here we can see a scatter graph of that data. As you can see, distance downstream against depth. So it's all the same data, all the same points. And we've also added there a line of best fit. So this has improved our interpretation of the data, as we can see the actual distances downstream. We've only plotted known data points, so we know that they are true as far as we trust our data. And this is better, or different, I suppose, because as you can see, if you compare the line of best fit and the change in level on the bar graph, you can see it's a much flatter trend line. So it suggests that depth going downstream does not increase as quickly as we thought it did. By having the bar graph, we've sort of over-exaggerated that trend. So in this case, we can more accurately interpret how river depth changes downstream by using our scatter graph. So here, the bar graph and the scatter graph were both correct. They were both good choices, but one is still better than the other. And I suppose that comes to our next skill about being able to evaluate different graphs, so the pros and cons of different types, and therefore being able to choose an appropriate one that will both match our data type, but also allow a meaningful representation of what that data is showing in our graph form. So let's have a look at some examples of this. I've tried to show as many different types of graphs as I can, but as you'll see by the time we get to the end, there'll still be some you might want to look at, and by all means, that's great. You can do that. You can make a note of what you'd like to look at as we go through. But there are quite a range of options just shown in these few exercises here. So in this next section, we'll be looking at this further. We've seen that there are different graphs and they have different purposes. And while several different options might be correct, each one has those pros and cons to help us judge which we can use and guide how far we can use them to draw our conclusions and describe our findings. In the handout, if you're using it, as we go through these next slides, there is a table there that can help you conduct an evaluation of each graph type. So as we discuss them, feel free to record your thoughts on the advantages and disadvantages, or the justifications and limitations, like terms you've come across for each one. Okay. Hopefully you've got that there. So on this first example, if I were to ask you which is best for showing the variation in environmental quality across an area of Ipswich, which would you suggest? Again, if you want to pop a reason in the chat, feel free to share, or share it among your class if you're watching with others. Which is best for showing the variation in environmental quality across an area of Ipswich? We've got two options here. We've got either the map here showing, or the aerial photograph rather, showing proportional symbols, and the other one is our pie chart. Well, they both have pros and cons. You might have suggested either. Let's just start first with the proportional symbols. The way you read it, first of all, just in case you're not sure, is the larger the circle or the symbol, the greater the environmental quality. So you need to be careful that you understand the scale or the key, but essentially the symbol on the map will be proportional to the data it's showing. So I've been round Ipswich in this case and judged the environmental quality based on housing and the street kind of quality. And I've plotted this across the area of Ipswich. So I can see that the larger circles seem to be around the north side of my picture, so that shows there's higher environmental quality there. That's how you read that proportional symbols graph. Well, what's good about it? If we were saying which is best, well, this one definitely does show the spatial distribution and how it varies across the area. I can clearly see that the larger circles are in the north and the northeast, showing that environmental quality seems to be better over there. I can also tell the sort of the way the geography might link to support that, because I can use the map behind it, or the picture behind it. I can see, oh, some areas are quite near areas of water and the marina, maybe it's quite nice there, improves the environmental quality, and because there's more open space, cleaner, something like that. So that's quite useful. It's also clear what is good and bad environmental quality. Large symbols, good; small symbols, bad. However, I would say, a kind of pitfall there, is if you choose your symbols, you need to match them to the scale correctly. So if you've gone out and done your environmental quality survey and marked 1 as best and 5 as worst, then your symbols will be flipped around, maybe not what you'd expect, so it might make it harder to read in the long run. So make sure you match them as well. So all those are good things about proportional symbols. However, there are still some drawbacks if you are doing this with your evaluation right now. For example, I can't tell what the most common environmental quality is. I can't tell what most areas around this area of Ipswich are. Are they mainly good environmental quality, mainly bad? Also, the range is quite difficult to tell. I can see there is a very small dot and a very big dot, but on the scale, actually that's just between 10 and 26. So quite difficult to instantly interpret the range. So let's look at the pie chart then. Maybe that was better. Is it best in showing the variation in environmental quality? Well, in some cases, yes. The range is much easier to calculate. I can see that on the scale at the bottom there, again, it goes down from 10 to 26. It's also easy to see the proportions. They're much more evident. So I can see what the general or average environmental quality is. I can see that there's 2 modal categories, the 10 to 13 score and the 18 to 21 score. That would be more difficult to tell from the proportional circles. However, there are disadvantages as well. You don't have the advantages of the proportional symbols located element. So nothing on that pie chart is going to help me explain why the environmental quality might vary across the area. So as I say, pros and cons for showing spatial distribution and proportions, but they are 2 options. And it might be useful to just note what type of data or what kind of patterns are best shown by proportional symbols and by the pie chart. Let's have a look at our next example. So here we're looking at relationships in data. So if I were to ask you the question, which of these, we've got a choropleth map bottom there and a scatter graph there, which of these is best for showing the relationship between crime and where it is occurring in Cheltenham? So which of these is best for showing the relationship between crime and where it's occurring in Cheltenham? Please move to have a think or a chat. So which did you decide? Again, there are pros and cons. I would have said that the scatter graph is easier to read off the relationship. Let's think about the pros and cons. So number one, the trend overall is clearer. There's clearly a kind of a positive correlation there, a rise. You can also tell the rate of change as well. So you can see that actually towards the centre, the crime ranking is quite low. So there's more crime there. And it quickly increases. So you don't have to go very far outside the centre of the settlement to see the level of crimes levelling off. However, this could be a bit confusing because the trend, it looks like a positive correlation. It is a positive correlation, that's what's marked. But the crime ranking comes from the index of multiple deprivation, which you may or may not have used. There's a link to it just underneath this slide if you download the PowerPoint, but that's where the map comes from as well. The index of multiple deprivation is a way that thank you, Kirsty, for taking more. I'll come to your comment in a second. The index of multiple deprivation is a way of ranking levels of deprivation across England. The lower the rank, the worse the crime kind of level of deprivation is, so more crimes occur in that area. And if you don't know that, you might interpret the scatter graph wrongly because it's kind of flipped to what you might expect. So it's a really important lesson in choosing the data set well, or matching it well to your type of representation. Many of you, like Kirsty, might think, in fact, that, yeah, the map is easier to interpret. The big pro of this one, the big advantage, is that it's a really visual representation. The IMD legend that you can see there shows the darkest colours as the most deprived, so in this case, most at risk from crime or most affected by crime occurring. So the legend makes sense, the scale makes sense. So it does make it very easier to read, but if you're trying to judge what the relationship is between crime and distance from the town centre, you, the viewer, the geographer, has to interpret that yourself. It's not a massive leap, but it is something that you need to kind of work out for yourself if you wanted to do that. Also, a couple of other disadvantages. It's not as precise as an interpretation as you might otherwise get. On the scatter graph, we've got the distance against the level of deprivation by ranking, whereas on the choropleth map, because we've had to classify it into groupings, the ranking is given as the deciles of deprivation. So you can only get to the nearest 10% within that. Also, it might be more difficult to show a trend line on it to aid interpretation or summarise it. Again, it's left to the viewer to kind of see what the trend is as you go from the town centre and towards the rural fringe and beyond. So there's a couple of options there. Both show relationships. But again, up to you in terms of the type of data you have and the best way you think it would be to choose a graph to represent that data. Let's try our next one. Okay, so remember, we're thinking about the pros and cons for each, which would be the best way, in this case, to aid your depth of interpretation. So how can we use graphical skills to help us interpret this data in as deep a way as possible? If I were to ask you, which of these would you choose to show the relative effectiveness of different coastal management options? You've got a bar graph there, and you've got a set of radar graphs, or radial graphs, you may know them as. Which of these would you choose to show the relative effectiveness of the different coastal management options? And I'll give you a mo if you want to chat about it or comment. So for an in-depth interpretation telling you about the relative effectiveness of different coastal management options, you've got the bar graph, the radar graph. I would say that the radar graph allows a more in-depth interpretation of effectiveness. Let's discuss why. Let's think about that. So in terms of how you use the graphs, I imagine most of you are familiar with a bar graph, but I'll quickly review it nonetheless. So at the bottom there, you've got your categories and the wooden groins, the different types of management essentially. The wooden groins, the crag walk, which is an area of rock armour, as you can see in the picture, and no active intervention, which you might otherwise know as do nothing, mandatory. And the bars represent their total score. So we've judged their effectiveness, given them a score, and the bar height shows the score. So from that, we can clearly tell that no active intervention or do nothing seems to have the best effectiveness on the management front. Now, while you might be surprised to hear that, there's no further information within that graph telling us how it got that score. So you might think, oh, well, how can not doing anything prevent be a really effective coastal management option? We'll see in a second. But while the pros there were clearly that it's easy to compare the different types of management, we can easily compare their scores. It's very clearly red, and you can read across to see the exact overall score they receive. And it's really clear which is which type of management. So the labelling on the x-axis clearly shows which is which. While there's nothing wrong with that per se, we've lost the detail, so that's our disadvantage. We've lost the detail in the type of data. We don't know how those scores were reached. You could, of course, create a compound or a divided bar to show those individual scores as well. Or the alternative, as we come across the other graph shown here, is the radar graphs. So how do these work? Just a quick overview again. For a radial graph, you might think they look a bit like a rose graph. They do look a bit like a rose graph if you've come across those. But for a radar graph or a radial graph, same thing, different names, different specs. You have categories, so discrete categories around the outside, such as tourist access, the lifespan of the management option, the cost of the management option, whether it's aesthetically pleasing, and so on. And then the kind of internal axes, if you like, so each step on the radar is the score that we've given it from 0 to 5. So 0 is a low score, 5 is a high score, showing they are very effective. So for example, if I was to give a management option an aesthetic score of 5, I would be saying that it's very effective in terms of how it looks. It's in keeping with the area, it looks nice on the coast, good for tourists, that sort of thing. So that's how you read them. However, what's good about these then that helps us over and above the options from the bar graph is that by reading each axis, you can see the individual scores. So you can see, for example, on the rock armour, the crag walk, it scored really well on lots of elements: aesthetics, appeal to residents, tourist access, lifespan, and environmental impact were all quite a good score. They were all 4 out of 5. However, the cost was right down at 1. So quite a low score there, suggesting it costs more than it's maybe worth, maybe more than it's protecting. So in terms of its cost benefit, it's not really benefiting us for as much as it costs. So that's great. We can tell the individual scores from these radar graphs. It's also still easy to compare the overall effectiveness because you just look for the one with the biggest kind of web inside the radar. But because we can also see the individual scores, you can work out what are the downfalls of that particular management option. So as I said, the cost is the downfall of the rock armour, the tourist access is the downfall of no active intervention, and the aesthetics, people didn't really like how drawings looked, the environmental impact, because they're made of caused sediment starvation further up the coast, they're made of hardwood, so not very sustainable. Maybe that's why they scored a bit lower there. And we can tell all that from these radar graphs. You can get much more sort of precise interpretation of it, which is great. But of course, they also have their downfalls. So it's difficult to work out the actual total score. Either you've got to kind of calculate it by adding them all up, or just, as I say, judge it from the overall look of the web and shape inside the radar. I would also add here that I have located these radar graphs, so that's great. You can locate bar graphs as well though, but if you can locate that data, then you can obviously connect the effectiveness in this case to the erosion that you see on the image, so it's just enhancing that graphical form a bit more. So you've got a range of pros and cons there, and we've come out with the idea that maybe radar graphs help with a greater depth of interpretation than a bar graph. Of course, up to you, depends on the data you want to show. Our final example in terms of choosing and evaluating the graphs is looking at the range within the data. So if I were to ask you for this data set, which of these graph options best shows you the range in the data? Is it the dispersion graph there, or is it the located bar graph, or the proportional bars? Which of these graph options best shows you the range in the data? A moment here. Okay, in this case, there is in fact a right answer. Only the dispersion graph shows us the range. Let's think about how we know that. So first up, how do you read that dispersion graph? Each dot is a piece of data, so we can clearly read from the y-axis there what the environmental quality score was for the maximum in St Aidan's and the minimum in St Aidan's, or equally maximum in Stanwix, the minimum in Stanwix. And by taking one away from the other, we can calculate the range. I have mentioned quite a few elements of measures of central tendency here. If you haven't, there's a geo tutorial. You'll be able to find them in the same place as this one afterwards, where my colleague Richard went over the ideas of using statistics in GCSE Geography. So if I'm using terms you don't quite know, make sure you check that one out. That'll be great as well. So as I say, by using the data points on that dispersion graph, you can work out the range. We can also clearly see the dispersion of the data and also the skew. So whether it's mainly a high environmental score, mainly a low environmental score, and therefore you can interpret from that the reliability of the data collection, perhaps, the variation within those places, and talk about the spread of that data in general. So that type of graph tells us quite a lot in that sense. It's also good, as I say, we can calculate the range and other measures of central tendency because we can read the individual data points. However, it is harder to compare the overall environmental quality between them. There's nothing saying, okay, what's the average, what's the mean, what's going on. And there's no spatial context, so we're not linking it back to that wider geography, maybe helping us to explain why the environmental quality might be different between the two places. Which brings us on to our proportional bars, or our located bars. Here, works a bit like a bar graph, it's just we've taken those bars off and put them on a map. So it's easy overall to compare the environmental quality between them, because you can see which is bigger, which is lower. The spatial context is there, as I said before, so that can help us support our geographical thinking, maybe why one has a higher environmental quality than the other, maybe to do with being near the river, being near green space. However, we weren't able to calculate the range from this or any other measures of central tendency, as only the mean value in this case is shown, the mean average. So a few pros and cons there to think about. And we'll just do a quick task to reflect on what we've gone over there, the pros and cons of different graph types and the types of data that are suitable to fit in them. Again, there's a task kind of set out in your handout if you're using it for this. On here, I've got two data sets, first of all. For these data sets, could you suggest an appropriate graphical presentation? If you want to put your answers or ideas in the comments box, it'd be great for everyone to see sort of the range of ideas people are thinking. And at the bottom there, for these graph types, so dot maps, histogram, scatter graph, suggest some geographical data that might usefully be presented in that way. So what sort of data would you present using these types of graph? Give you a few minutes to do that. UK. So let's think about maybe the thinking process you might have gone through and the conclusions you might have come to there. So for our ecosystem data, it shows the ecosystem and a number of species that live in that type of ecosystem. So you've got discrete data here, you've got counts or numerical data as integers that apply to each category. Therefore, you might have chosen a bar graph. That would be appropriate. You'd have your x-axis with the different categories, the desert, the temperate forest, and so on. And then the size of the bar would show the number of species that live there. For our next one, let's think about the type of data there is. So this is infiltration rate, so how quickly water soaks into different, a given type of soil, rock, sand, that sort of thing. Our data here is continuous, both the time and the infiltration rate in milliliters per hour. Therefore, you might choose to show it on a line graph. Because they're both continuous, you would be able to sort of work out for a given number of seconds what would the infiltration rate be. And also, it's not a distinct point in time. Although we might have measured that the infiltration rate after 90 seconds was 20 millimeters per hour, it will have transitioned into that from 36, and it will continue changing to 18 millimeters now over the next 30 seconds. So because they're continuous, a line graph will be appropriate there. And what about for the suggested data sets for the graph? There are loads of different answers, but I'll give you a few to help you in case you couldn't think of anything, but that doesn't mean your suggestion is wrong. Definitely check it with the teacher, maybe with each other. If you're still not sure. A dot map, for example, might be used to show population density. So maybe you might have one dot represents 100,000 people, and then obviously you'd be able to see, due to the density of the dots, what the population was across a given continent, country, whatever it was. A histogram. Here we want to show maybe something like pebble sizes on a beach. So if you've gone to a beach, you've sampled a series of pebbles, we might expect some to be really tiny, some to be really big, and a variation across that in the middle. So a histogram would easily allow us to show the range of those, and it would show us the mean as well. Scatter graph, what could you do for this? I have shown you some examples already, but another one might be maybe looking at sound levels measured in decibels against traffic count data. So they're done in a series of locations maybe, and for every traffic count you do, you could plot against it the sound level, and you'd be able to see, well actually does sound level change according to the traffic count? Maybe you might expect higher sound levels where there's more traffic, that sort of thing. And you'd be able to tell that from the relationship shown on your scatter graph. So hopefully you found those okay. If you didn't, don't worry, you can always note that down a bit later on to be something that you want to return to and practice. It's just to give you an idea of the types of skills you might need and engage with in your GCSE. Moving on then, we've thought about a few skills behind us, or we've got a few skills behind us to think about how to choose a graph or suggest one for data that would be appropriate. And hopefully you'd be able to evaluate them, as we've seen a few examples there. But what about actually doing the graph, completing the graph? There is a little task in your handout here, or you can just make some notes. What I'd like you to do, please, is write a list of success criteria for completing a good graph. I'll just give you a few moments to note some things down. You might draw on some of your knowledge from maths as well to help you with this, or drawing graphs in science. All of that will help you to make connections between subjects that support your idea and your understanding. So I'd say there's some classic ideas of what you'd include here, and you can make use of this list when you're practicing exam questions or drawing your own graphs from data in class to help you make sure you're creating good quality graphs. So we have, it needs to have a meaningful title that clearly shows what the graph is about. You should label your axes, show what they show, and also the units. You should use effective scales. So an appropriate minimum, maximum, not misleading comparisons either. If both axes are showing in meters, don't make one really stretched out and one really squashed, because you'll make the trend look really weird. Plot it as well with a sharp pencil when you're drawing your graphs for accuracy. And use a ruler rather than a kind of sketched line if you are doing or putting in straight lines. Use a scale or a key if that's required for your graph type. Essentially make sure that ultimately, as it says here, the graph choice or the construction should not mislead the reader's interpretation of the data. So as long as you look back at your graph and think, yeah, that tells the viewer, the reader, exactly what's going on in my data, then you'll have done well, a good graph. However, it's not just completing a graph that you might be asked to do in an exam. You also need the skills to be able to extract data, interpret that data and say what the graph is showing, and analyze it. So maybe drawing comparisons between things or evaluating the quality of data, that sort of thing. So just here, we're going to have a practice of this. These are all, or these are both, this slide and the next, exam style questions. Okay, so they come from a particular exam board, but they use command words that you should be familiar with. So for this one here, as I say, you may need to continue practicing this or completing different types later. But in this example, I'm showing you a desire flow line map showing Greek trade. This data is referenced underneath. It's from the BBC if you wanted to look at it in more detail at some point. But this is a desire flow line map. And I would like you to complete the question, describe the main patterns in imports and exports for Greece. Let's just take a moment to bug that question, if you use that term. I'm sure you'll have approaches you take when you're approaching an exam question. But if we box the command word, our command word is describe. So we need to describe means we need to say the main trend. Say what it's like. Then we might underline some key terms. So we want to know about the main patterns, and we want to know about imports and exports. So we've got to write about all of those elements. And then the G is just for going over it and checking what we need to do before we write an answer. There is space in the handout if you want to make notes on your answer there. Otherwise, you can have it all on the paper. I'm not going to give you very long to do that. If you are watching back, obviously you can pause it. If you're not watching me now, we'll just think about those main points that you would put rather than writing out in prose. But essentially, I'm going to show you an example answer now, which just highlights to us, not necessarily exactly what you might have written, but how you can make use of this graph, in this case, to help your answer, make it as good as it can be. So here I've written an example answer. The highest value of Greek exports go to Brazil at 40 million. This is twice the value of exports to Canada, Russia and Japan, and 4 times as much for the UK. The highest value of Greek imports come from Russia, valued at 40 million again. Similar amounts of imports come from Japan, Brazil and Canada, whereas the UK trade least with Greece, with imports valued at just £10 million. The total value of exports and imports is balanced at £110 million. So let's just pull out what's important now. First of all, I've drawn out the things marked in blue. And these are the comparisons. I was asked for the main trends on imports and exports. So the main features, I pulled out the highest, the lowest, what's similar, that sort of thing. In yellow, I've supported those points with evidence. So I've used the scale at the bottom of the graph here to measure the width of the arrow in this case, which shows me the value of the imports or exports. And I've put that in my information. But I've also gone a bit further with the things marked in green. Here I've manipulated that data. So I haven't just lifted it and directly read the graph, although that is fine. But I've also kind of summarized it by saying things that are twice the value, 4 times as big, and so on. And finally, the other important thing you should pull out of graphs is shown here in pink, and that is the overall main trend. So I'm looking for describing the main patterns in imports and exports, and I've summarized it with a total imports and exports, which in this case happen to be balanced. So you can see there how you might use a graph in an exam question to help you evidence your answer. The comparisons help you interpret that data, and overall your analysis is there to show you what the overall trend is. Okay, let's have another go at a different type of skill that you might see in an exam question. So in this part of using graphs, we have a compound bar graph. So before we go into the question, just a little brief moment on how to read this type of graph. Essentially, it's a bar graph. So again, the total height of the bars show the total, in this case, the area covered by different land uses in 2 settlements. But the different colours on the bar relate to the different land uses. So on a compound or divided bar graph, the bar is divided into different categories. As a whole, they show the total, and as sections, they show the individual values for the different parameters. So for example, I can read from this that in settlement A, the residential land use is 60, because that's where it comes up to. Then the commercial land use in settlement A is between 60 and 65, so I can calculate that will be 5% of the total land use. Okay, so that's how you work a compound bar graph or a divided bar graph. This is another exam style question and a commonly required skill, commenting on or using another study, their data in that unfamiliar scenario, and their data presentation, and commenting on that, working something out from it. Okay. In fact, in this year's GCSE, that's the end of the game in terms of fieldwork. So here, your critical thinking and your evaluative skills will be needed. So here's the question and the scenario. A student wanted to compare the quality of life in 2 towns and collected data on land use to do this. They have presented their data using this compound bar graph. Your task is to suggest one advantage and one disadvantage of presenting land use data in this way. So the command word suggest is asking you to give a reasonable, a common sense option, in this case for one advantage and one disadvantage. So you wouldn't get marks for 2 advantages or 2 disadvantages that are correct. You need one of each. And you're talking or you're commenting on the way that this data presentation option, this graph, represents land use data. Again, I'll give you a moment to think about that. There's space in the handout if you're using that. So let's have a think about what you might have put there. Something that is quite a common go-to when you're sort of evaluating different types of graphs is whether it's a good visual representation. You see it all the time, and that's fine. But if you can, try to say why it's a good visual representation, because that is an advantage of this graph type. In this case, it's an easy visual representation to compare for each land use. By using the coloured key, you can easily work out which town has the biggest amount of residential, has the biggest amount of commercial, and so on. However, it's also possible, as another advantage, just to give you some options, within each settlement you can see the minimum and maximum land use type. So for example, in settlement A, the majority of area is taken up by residential land use, and the smallest area is the commercial land use. So there's a couple of advantages there. Remember, you just needed to list one. What about the disadvantages? Well, it is quite difficult on a compound bar graph to work out the exact percentages of land use, as you essentially need to calculate it from the bars. So like I did in my example, working out that commercial land use was between the 60 and 65% marker, therefore being 5%. of the land use overall, you need to do that calculation, and that's not very easy to calculate precisely. Also, there's no idea of relative size of the settlements here. Therefore, the actual amount of land use in each place is only a percentage comparison. We can't, say, oh, there's much more residential land in settlement A, because settlement A might be a tiny place. Because, however, they are both 100% at the top, it seems like the settlements are the same size. So that's maybe a slightly misleading element that we might draw out of this example on the compound bar. Okay, hopefully you feel you're doing okay so far. However, if there is anything that you feel you'd like to go over, we've kind of come to the end of the session now, or towards the end of the session, and I'd just like to give you a few moments to reflect on what we've done. So we've covered a fair bit. We've reasoned why we might choose a certain graph as appropriate, maybe the data type, maybe the purpose of the graph, and we know the pros and cons of each as well, so that's as needed in your spec. However, also we've seen how you might need to use and interpret graphs, using evidence from them to help your analysis. And as I say, do check back in your own spec to see exactly what you need to know. So as a reflection, I'd just like you to think about 3 things you've learnt. There's a preliminary triangle on your handout if you're using it. 3 things you've learnt, 2 to practice, and 1 to find out. Luckily, there's loads of opportunities to do this all over the place. We see graphs all the time, such as the 3 kind of contemporary ones I've shown on this slide. Again, they're referenced if you want to go and look at that data. Read them, use them in conversation, evaluate them as you see them come up on the television. Just because they're published doesn't necessarily mean they're a good graph or appropriate, so it's always worth thinking over. And you can really engage as well. There'll be graphs on, sports, on your interests, on football, on game stats, diversities, on kind of stories in your local communities, all sorts of things you will find data on and be able to evaluate graphs for. So hopefully this bit of revision might be a bit more engaging, a bit more interesting directly and personally to you. So there's a space there, as I say, if there's anything you feel you need to go over, make sure you note it down there in that reflection preliminary so you can really focus your way forward on this graphical skills skill set for your GCSE specification. And I'll just leave you with a couple more slides. I'm not going to talk through them, that's what we've covered, because the last slides on this PowerPoint feature links to further support. So there are things for both teachers and for students, different areas of support linked all there, and you can choose whatever seems relevant to you. I can see there are no questions on the side yet, but do you put any up? They're burning, and we'll see if we can address those. Otherwise, hand back to Aaron, and yeah, well done on that. Hopefully, you'll enjoy looking through graphs a bit more now with your GCSE specification.
Thanks a lot for that, Charlotte. That was great. Yeah, I don't think there are any questions, but we'll just give people maybe a few more seconds to do so if they do have anything to ask. Just a reminder again, you can find the presentation from this session on the event page. It will be in the past events section, and you can also find the live stream if you want to go back and watch it. You can also explore that past events section if you want to look back at any of the other sessions that we've already done. And yeah, please feel free to check out the rest of the GEO website because there's lots of useful stuff up there, and we're adding to it all the time. So there's web inquiries and quizzes as well, with more to come between now and Christmas. So yeah, do go check those out. Yeah, I don't think there are any more questions, so I think we'll end it there. Thanks again, Charlotte, and hopefully see some of you next time.
Thank you. Well done, everyone.